Hello everyone, welcome back to Blockchain Training Webinar. My name is Fu Chendong. Thank you for joining us again. The topic of this session is Blockchain Technology Overview. I'm going to introduce the key technologies of blockchain, how blockchain works, and what we can learn from blockchain's innovation thinking. In the last session, we have learned that blockchain is a public distributed ledger. The blocks that record transactions are linked one by one in chronological order by chain. Once the block is added onto the chain, nobody can modify or delete it. To do this, blockchain technologies need to address several key issues. First, what's in the block and how the blocks are chained in the chronological order. The key technology here is hash algorithm. Secondly, who can add one block onto the chain and how to prevent the blocks from being tampered. The key technology here is consensus mechanism. And then, how to make the transactions safe. The key technology here is asymmetric encryption. Finally, how to build programmable and extendable blockchain. The key technology here is smart contract. None of the technologies used in blockchain are blockchain-specific. Many of the technologies have been there and used decades ago. And blockchain is just a combination of these technologies. We can see blockchain is standing on the shoulders of its predecessors. Next, let's go through each of these key technologies. Firstly, let's have a look what's in a block. Let's take the Bitcoin block as an example. A block has block header and block body. The block header is the summary of the block, includes version, timestamp, previous block head hash, block body mock root hash, and so on. The length of block header is fixed. For example, 80 byte for Bitcoin block header. The block body includes all the transactions, which are organized in the form of a marker tree. Every transaction, which is the leaf of the tree, is labeled with the hash of the transaction, and every branch of the tree is labeled with the hash of its child nodes. The marker root hash is derived from the hash of all transactions included in this block. In the block header, the previous block head hash points to the previous block header. Actually, this is the chain that linked the block with previous block, and the next block linked to this block in the same way. That's how the blocks are linked one by chain. The marker root hash establishes a link between the block header and the block body. This is another inner chain of the block. Here there is a keyword, hash. What is hash? Hash is a mathematical algorithm that maps arbitrary size message to fixed length digest. It's a one-way function. That means the function is infeasible to reversed computation. One message input has only one unique digest output, but you cannot guess the input just from the output. It's collision resistance. Each block in blockchain has a hash, and each transaction in one block has a hash too. Let's have a look at why hash algorithm prevents blockchain from being tampered. For example, someone tried to tamper with the transaction B in a block, and then the hash digest of transaction B will be changed, and then the branch hash will be changed, and at last, the marker root hash of the transactions will be changed too. This results a change of the hash of the block header. What does that mean? That means the link between the subsequent block and this block is cut. The blockchain is broken. How to prevent such kind of tampering? The answer is consensus mechanism. We know that blockchain is a peer-to-peer and public network. Everyone, including users and miners, behaves freely in the network. But there is only one chain of blocks in the blockchain network. So we did consensus mechanism to build the rules of blockchain network. There are two main kinds of rules: creator selection rule and chain selection rule. Why creator selection rule? Because lots of miners are trying to create the same block at the same time. Who is selected to be the creator of the latest block? Why chain selection rule? Because maybe two or more miners might have found the same block at the same time. This causes the fork of the blockchain. Which chain will be finally selected to be the correct chain? There are many consensuses, such as proof of work, proof of stake, practical Byzantine fault tolerance, and others. Here I just introduce proof of work and proof of stake. Bitcoin network uses proof of work consensus mechanism. The proof of work requires the miners to scan for a nonce in the block until a value is found that gives the block's hash the required 0 bits. Only block with a valid nonce could be added to the chain. This process is usually called mining because miners often do hundreds of billions of calculations to find the right nonce. In Bitcoin network, it takes about 10 minutes to generate a new block. The objective of proof of work was to select the creator and the chain. The longest chain is most believable as the valid one because it has the most computational work done to generate it. In blockchain network, it is nearly impossible to create new blocks that erase transactions, create fake ones, or maintain a second chain. To do this, a malicious miner would have needed over 51% of the network mining power to beat everyone else. It is a mission impossible in a peer-to-peer network. A major criticism of proof of work is the consumption and waste of the energy. Initially, eLearning used the proof of work consensus, but on September 15, 2022, eLearning translated to proof of stake consensus. In proof of stake consensus, a user must deposit 32 Ether into the deposit contract to be a validator. The validators are then responsible for creating new blocks themselves or validating that new blocks appended to the chain are valid. Proof of stake consensus has many benefits. For example, it improves energy efficiency by reducing a lot of computations. After transition to proof of stake, Ethereum will reduce the energy consumption by 99.95%. Proof of stake also reduces the cost of miners. There is no need for hardware to stand a chance of creating new blocks. Another question is how to protect transaction security in a public network. Blockchain uses asymmetric encryption to increase the security. Asymmetric algorithm uses a pair of related keys, one public key and one private key, to encrypt and decrypt the transaction message. The private key is to prove the ownership of an account, and the public key is to be shared publicly to verify a digital signature. When the payer broadcasts the transaction in the blockchain network, the transaction will be encrypted into a digital signature by a private key, and then the transaction information, digital signature, and the public key will be broadcast in the blockchain network. When a miner collects the request, he will use digital signature and public key to generate digital validation, and then compiles the transaction hash to validate the transaction. Finally, let's talk about the smart contract. A smart contract is simply a program that runs on the blockchain, for example, Ethereum. Smart contract simplifies the process in multi-parties agreement. When two or more parties have an agreement, for example, make a loan, a smart contract will be developed and deployed on Ethereum. Once the smart contract has been deployed on blockchain, nobody can change or delete it. The smart contract will be automatically executed when the agreement conditions are met. The outcome of the smart contract is predictable because it is coded in program. This helps to remove the human interference. Smart contract builds the foundation of Ethereum, making Ethereum one of the most active and popular blockchain networks. Smart contracts have also allowed blockchain applications, extending from cryptocurrencies to many practical scenarios, increasing the value of blockchain. That's all for this session. Let me make a summary. Blockchain is not a purely new technology. It is a combination of existing technologies, such as hash algorithm, consensus mechanism, asymmetric encryption. Some of them were existed decades already. What we need to learn from blockchain is not only the technologies it uses, but also the innovation thinking in creating new applications by out-of-the-box technologies. Thank you for watching and see you next time.